which are essentially fragments of words, phrases, figures, and punctuation. This colossal training required the equivalent of 30.84 million GPU hours and produced the equivalent of 11,390 tons of CO2 emissions. It's a massive undertaking, but the results speak for themselves. Now, this model has been trained on 16,000 NVIDIA H100 GPUs. These are top-of-the-line GPUs that are essential for handling the immense computational load required to train such a large model. Despite its size, Meta claims that the Llama 3.1405B can go head-to-head with some of the biggest names in AI, like OpenAI's GPT-4 and Anthropic's Claude 3.5 Sonnet. That's a bold claim, but Meta's experimental evaluations suggest it's competitive across a range of tasks, from generating prose to answering chat responses. Now, one of the most exciting aspects of Llama 3.1 is its openness. Meta has released this model as open source, which is a big deal. In the world of AI, open source means that the code and the model are available for anyone to use, modify, and improve. This approach has a lot of benefits. For one, it allows for a broader ecosystem of developers and companies to build upon the model, creating new tools, services, and applications. It also means that the technology is more accessible and can be used in a wider range of applications, from academic research to commercial products. Meta has also rolled out updated versions of their smaller Llama models, the 70B and 8B variants. These models have been upgraded with support for 8 languages: English, German, French, Italian, Portuguese, Hindi, Spanish, and Thai. They've also been given a much larger context window, now supporting up to 128,000 tokens. A context window is like an AI's short-term memory. The bigger it is, the more information the model can hold on to at any given moment. This is particularly useful for tasks like long-form summarization or coding assistance, where a lot of context is needed to generate accurate responses. One of the challenges with running such a large model like the 405B is the hardware requirements. At 405 billion parameters, it requires roughly 810 GB of memory to run at the full 16-bit precision it was trained at. This is more than a single NVIDIA DGX H100 system, which has 8 H100 accelerators in a box, can handle. To address this, Meta has released an 8-bit quantized version of the model, which cuts the memory footprint roughly in half. Quantization is a technique used to reduce the precision of the model's parameters, which makes it more efficient to run without significantly impacting performance. Now, let's talk about why this matters. For developers and organizations, the open source nature of Llama 3.1 means they can train, fine-tune, and distill their own models. This flexibility is crucial because different organizations have different needs.